In number 67, in order to, in this case, it was a, I do believe, it was a very annoying one. I do believe this problem said solve by any means possible, correct?
Yeah.
All right, now here's kind of the curveball in this case. Did I show you guys how to do quadratic formula before you went home?
No.
I did, didn't I?
No.
I did.
He gave us the equation, remember?
Yeah.
Oh, that one huge equation.
Set one side equal to 0. You get 3x squared minus x plus 6 is 0. If I'm going to factor this, it'd be what times what is positive 18 to add together to get negative 1. There isn't anything. The next thing I would do is I would think about completing the square. Now, I can complete the square here, move c, divide everything out by 3, but then I have to worry about completing the square with a fractional b value. I can do it, right?
Yeah.
It's just not going to be any fun. So, when all else fails, what are you going to use? Don't quit. Use a quadratic formula. To be honest with you, on this case, I would be using the quadratic formula. I know it's in the completing the square section, but when it comes down to the test next week, which is next Wednesday, when it comes down to the actual test, when it says solve by any means, if I see a problem like this, I'm going to go, quadratic formula. So, opposite of b, positive, plus or minus the square root, b squared minus 4 times 3 times 6, all over 2 times 3. In this case here, I wind up with, well, what's 1 squared?
1.
What's 4 times 3 times 6?
72.
What's 1 minus 72? So when I do that, I'm just going to simplify the 71, and I wind up with the final solution of 1 plus or minus I root 71 all over 6. And that's how I would solve that problem. I would not try to complete the square on that. Okay? Yes, sir? No, you can't simplify it any further. I know the back of the book would have given solutions a little bit differently.
Yeah.
The back of the, and here's what the back of the book is doing. The back of the book is breaking it apart as this. They're breaking it apart. Okay. Or sometimes they're joining them together. If you stop right there, that's fine by me. Okay? Yes, sir?
Will you do 37 for page 95?
How about the completing the square one? Is there any more on the completing the square stuff? I'll get to that one. What do you got?
How about like
88?
okay. 88. Wait, what?
On the completing the square?
Oh yeah, we had that. I didn't have any 88.
Yeah, page 287.
48.
Oh, there it is. 88. Sorry. Like, did I assign that? All right, area of the parallelogram.
Wait, 88.
Hey, Mike. Better bracelet.
Area of a parallelogram. Base times height.
Actually, bad bracelet.
Subtract 54. What times what's negative 54 you add together to get positive 5, or negative 5? Well, let's see. 8 doesn't work. 9 and 6, so that's about it. Yeah. So here, if I want to complete the square, I think, did it tell you to complete the square on that one? I think it probably did, didn't it? Oh, it just said find the value of x. All right, so there's no rule for whichever one you had to do. Once again, I use quadratic formula. It's easier. I could take and complete the square. It's not that bad. But here, if I do this quadratic, I go opposite of b plus or minus b squared minus 4 times a times c all over 2a. So let's see, 108 and 108 is 216. 25 and 216. So it's 5 plus or minus the square root of 241 all over 2. Since you're dealing with area, do I want a negative value here? No. So which one of these would I be able to throw away right away? The negative. Which one's going to be the negative? The 5 plus the root 241 or 5 minus the 2 root 41? That would be the answer, yeah. The minus one will not work. So you just cross it off. And that's all you got to do. I don't believe there's a perfect square that goes into 241. I don't think so. All right, does that make sense?
Can you do like 57 on page 287?
All right, let's go to the other one then. It was 55 was the first one, right, Ryan? You want to look at? That we were talking about? The discriminant stuff, the quadratic formula?
Page 295, 37.
Oh, 37? Okay. We'll look at that one first. Then I'll get to that one. All right. In this case here, the first thing I want to do is figure out what everything is. So I get 0 is x squared plus 16x plus 46. Let's sing the song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay. Let's see. 46 and 46 is 92. 92 and 92 is 184. So I have 256 minus 184 gives me 72. So I have negative 16 plus or minus 6 root 2 all over 2. Now the back of the book probably gave you solutions as negative 8 plus or minus 3 root 2. Is that what I get? What I did there is I simplified the square root of 72 off the top of my head. I knew that was 36 and 2, so it was 6 root 2. And then since everything is divisible by 2, I just simplified out the fraction. Okay. Does that make sense? Speaking of quadratic formula song, this week, let's see, we have today, we're going to combine 5, 5, 5, 6. Tomorrow, 5, 7. Wednesday, 5, 8. Thursday leaves us a half day again of another 20-some-odd minute period. Well, instead of trying to blister through 2 sections, we're going to do something a little bit more interesting. You have an extra credit assignment.
Sweet.
You are able to create your own quadratic formula song.
Can we do it in partners?
Yes, you may.
Oh my.
Now, here's the thing. What's that?
Can it go on my album?
It can go on your album if you'd like, but I have to hear it on Friday.
Alright.
Does anyone else like to hear it or just you?
Us.
Wait, so
Now, it can be, I'm going to answer all the questions here in a second. Now, when we go to assign this, there's a couple of ways you can do this. You can perform live, or you can perform it as sort of a video if you'd like. If it is a video format, throw it up on YouTube. It's easier for us to pull it from there. Okay, does that make sense? You guys all know how to do that, I'm assuming, right? Or if you have it on a flash drive and you want to throw it, and you
What's
just.
the group maximum, like the number of people?
I don't think I've ever had any more than 3. I like to keep it that way. It's a pretty fair workload. So, yeah. So I usually make it depending upon how interesting and or enjoyable it is.
we need a chorus.
I get last year. If we have time later on, maybe Wednesday we'll have a little bit more time. I will show you guys some of the ones I had last year. I had one last year that was just pretty awesome. But it was pretty funny. But yeah, that's kind of what it is. It's nothing crazy. It's fun. Make sure it's school appropriate. You don't have to if you don't want to.
All right. Wait, is the one video we watched about dudes killing dudes appropriate?
What?
Yes, because I showed it in class. So just make sure there's no swears, no swearing. Yes, sir.
How much is it?
I usually make it worth about 3 homework assignments because what happens is I put the value. I usually throw the value in on the quiz grade because it's weighted a little bit more. I've never given 0 points for it, and I don't think I've ever given more than 10 points. It's just, 5 points on a quiz grade is a lot. So it's what's that?
Is that required?
No, you don't have to do it. If you want to, it's fine. Do you have to? No. What was the next one you were saying? 55? Is that right? You want to look at 55?
Yeah, 57.
Yeah, 57.
Okay. To find the discriminant, when you're working with the discriminant, when it asks you to find the discriminant and how many solutions does it have, remember, the discriminant is just the stuff underneath the radical, b squared minus 4ac. You don't take the square root of it. You don't do anything with it besides. The discriminant, remember, is b squared minus 4ac.
Oh.
So that is 9 minus 4 times 1 times negative 6. 9 plus 24 is 33. Is that positive, negative, or equal to 0?
Positive.
It's positive, so how many solutions does it have? 2 real. Remember, if it is positive, if the discriminant value is positive, that means you have 2 real solutions. If the discriminant is negative, you have 2 imaginary solutions. And lastly, if the discriminant is equal to 0, you have 1 real solution. All right, that's how that works. What was the other one you wanted? Was it 55? I remember you said?
57, page 287.
That was 57.
On page 287?
Oh, no, that was the other one. I'm sorry. That was backwards on that one.
It's all good.
Coefficient not equal to 1. Yeah, this is when you got to do a little bit more work. So whenever you're working with completing the square and your coefficient is not equal to 1, the first thing you got to do is make your coefficient equal to 1, which means you have to divide everything by that coefficient. So divide everything by 6. I get x squared plus 14x plus, what is that, 50. Now, in order to finish completing the square, the next step is to move c. How do I move c? Subtract. So I have x squared plus 14x blank equals negative 50. After we do that, we take half of b. Well, what's half of 14? 7. What do I do with that 7? You remember right away?
Square it.
But what else do we know that it's part of? Remember that? This value automatically goes there.
14?
Actually, I didn't have that memorized.
We talked about it.
Oh, that equals 14. Okay.
When you squared it, did you just write 14?
No,
I should say as equals to the same.
I thought 84 divided by 12 is 12.
Well, 84 divided by 12 wouldn't be 12 either, but it's
It would?
84 divided by 12 is
84 divided by 6
is 7.
is 7? Wait.
No, wait, no. I'm sorry, 84 divided by 12. It's 84 divided by 12 is 7. 84 divided by 6 is 14.
Yeah, I thought 84 divided by 6 equals 12.
Oh, that's why you got it wrong then. So now from here, we wind up with x plus 7, quantity squared is equal to negative 1. Remember, when you take the square root of both sides, when you take a square root over an equal sign, what do you write? Do you know how many times you guys didn't do that on your quiz? Negative 7 plus or minus I. That's your solution.
Wait, how is...
I did.
No, it's.
I don't think.
Oh, because...
What's that? You wrote the plus minus? I hope so. A lot of people forgot that. It was a very common mistake.
I didn't balance.
Hmm? That you, exactly. That you. What else we want to look at? Are we all good on these? All right. Here's what I want to do today. I want to take this just one step further and talk about why we use parabolas and how you use them to make things. No, I'm going to have you guys turn in the stuff we did tonight. I want to talk about some initial velocity stuff. So, whenever I throw something, it's a golf ball, yes. Watch the trajectory. What is it doing?
Oh, it's because of gravity, of course.
It goes up and down. So when it goes up, it comes down, right?
Yes.
What does the path of the ball look like?
Parabola.
It looks like a parabola.
Right, but verbally thrown your golf.
Because gravity accelerates.
Gravity doesn't make it accelerate. Gravity is constant.
Gravity makes
Guarantee you're going to miss it next time you're doing it.
This?
Oh, I think you got something.
No, it was from the marker of the ball.
Something.
Yeah, it's coming out, I think.
Something like
That might fall.
you'd like to take.
Yeah, it'll be all right. It'll come out. Just a
Something like
scratch.
that.
There's no gouge. It's just it's merely a flesh wound, right? It'll go away. It's just dirty.
That's what I did to
Okay.
No, it shouldn't hurt the smart board.
I don't know. It's really scary because I don't want to die at me.
Who has the ball?
I think he ate it.
Who has?
Cassie
Anyway.
does that.
So here's what I want you guys to think about.
You're not even a good liar.
It's terrible.
Every time I throw something, no matter what I throw, I hit a golf ball or whatever I hit. When you throw something, gravity causes it to drop. Whether it's a baseball or anything like that, at some point in time there's an arc to it and it comes back down. Now, when you're talking about with a golf ball, it's pretty easy to think of. You start it at the ground, it goes up, and it ends at the ground. Right?
Well, it starts with your hand and ends at the ground.
Well, you know what I mean. Okay.
Not if you're hitting it.
What happens here is if I wanted to figure out specific distances, if that's my starting point, and that's my ending point, what occurs halfway across? The maximum. Now the maximum value occurs here. Now, if this is a maximum value, that meant my A value is what? Negative. It's down like a frown. A was negative. That meant my A value had to be negative. My maximum occurs there. What is another term for the maximum of that parabola? It's the
Climax.
vertex.
Vertex.
It's the vertex. Okay? Now, if you're going a horizontal distance, is that dealing with your x values or your y values? It's dealing with your x values, okay? Now, what is the x value at the maximum here? It's half, isn't it? What is it also called? It's the axis of symmetry. So the x value is your axis of symmetry here, and it's also the midpoint of the axis. Because if you think about what's going on, if I wrote this in terms of, remember, intercept form, x minus 0, x minus 6, or whatever, that value is the midpoint of the two. 0 plus 6 would be 3. There's your axis of symmetry, and so on. Now, what they're able to do with this, what's called modeling. Oops, one. We are looking at two specific equations. This modeling comes from, and these are going to be given to you in these types of problems. They're going to give you an algebraic model to what the parabola is looking like. If you take an object and you just drop it, there's no velocity to it. It's just a height and you let go. Let gravity do its thing. So on, okay? If I have velocity to it, that means I'm giving it something behind it.
Little
Some
cat.
oomph, okay? I'm giving it some oomph going across. Excellent. I need to get a bounce ball. Much better for us. So that's why there's two different types. So we're looking at a problem, and I have one here.
Did you draw the golf ball like it was a basketball?
I don't know where I got that from. I found that on the floor one day, and I just put it in my room. I figured at some point in time I was going to need a golf ball for something. Visual representation. It makes me think about going outside to play golf, which I would love to, but I can't. Thank you.
Well, it is pretty
Feel
cool
sorry.
outside, Mr. Murphy.
It was, I think it was our last year at the old building. Parent-teacher conference week, the Friday. We had myself, Mr. Polscota, Mr. Severino, who else was there? I think it was just the three of us. We've been planning on playing golf on that Friday because we have a half day. We're done at noon or whatever. And we were watching the weather. The weather was supposed to be 65 degrees and sunny for right around noon, but later in the afternoon, the temperature was just supposed to drop. It was supposed to be snow flurries by the evening. We got up and teed off at about 1 o'clock over at Oak Club in Genoa. teed off 60 degrees, beautiful. I was up all the way.
I can do that.
By the time we got to hole number 10, the temperature had already dropped to 45. By the time we had finished out, it was flurrying, and it was like maybe 33.
Is that
So,
fun?
oh, it was great. We had a blast. So we finished. We had the last round of golf that year. Had a little, we finished up in a little bit of snow. It was good times.
Who won? I knew it.
Sure you did.
No, it's true. Seb is dangerous though when he plays. He's dangerous. He's got
I
his
know.
hook. He only hits it 125 yards, but he goes, I mean, every time he goes, shh. And he's got this hook that just keeps going back out
Darn
I can see
lefty.
Seth having weird.
there. He's got this weird thing.
Yeah.
It just goes, he's left-handed, whatever's going on. And, so anyway, here's what's going on. When you're looking at these problems, they're going to give you guys a model to work with, or you're going to have to reuse that -16 whatever squared. Now, when we come to the test on this stuff next week, if there's a modeling problem, I'm not going to require that you guys memorize these formulas for initial velocities and stuff like that. I will give that to you. This is a very simple setup. If any of you guys take physics, you're going to see this kind of stuff a lot. Egg drop, all those types of things. Your what are those? Catapults. You can use all this stuff to model this stuff out. Now, what I'm looking at here is you've got somebody playing basketball. Really oversized basketball, but that's okay. You're playing basketball. How high up is the hoop?
10 feet, right?
Yeah.
10 feet more.
So your hoop is 10 feet up in the air. All right. Thank you. From there, the ball starts with an initial height of 5 feet, and you've got somebody up here going in for the alley-oop.
Wow. I can jump.
Baseball?
So, what they're talking about here is you're using one of these models. Let me bring this one in here. When they say in the problem itself, if you read through it, the ball starts at 5 feet. The person that catches it grabs the ball at 11 feet. The ball starts at 5 feet above the court with an initial velocity of 21 feet. So if it's telling you that you're going to have an initial velocity, which one of these two are you going to use?
C.
The second one, because this V sub O stands for initial velocity. This H sub O stands for initial height. And then H stands for the height. So we wind up using the model of, oops. The model, oops, yes.
So it's -16.
Yeah, because it's a physics problem.
Really? It's always negative things bad? No matter what?
That's the model. They're going to get, the model might be different depending upon the problem, but in this case, this is the model that they're using. So what they're asking us to figure out is how long is the ball in the air before being caught? So when you start the ball at 5 feet, and it's got to end up at 11 feet, it's on its way arcing up, okay? So it's on its way arcing up.
Wow.
Thank you. How do you solve for time?
Whoa.
It's the X value.
It's the x value, yeah. In this case, well, what are you going to use? Oh, why? Do you agree if you set one side equal to 0, right?
Yep.
So 0 equals -16t squared plus 21t minus 6. Do you want to factor that?
No.
Do you want to complete the square?
No.
So what are you going to use?
The quadratic formula.
Use the quadratic formula, guys. Seriously. Distance formula, I know. Legs are falling apart.
Got crazy today.
Brilliant. You're bending reality as we know it.
Use your quadratic formula. X equals the opposite of b plus or minus the square root of b squared. All I did was just square 16 minus 4 times A
Wait, what's
times C. What's that?
Wait, is that A squared or B squared?
X equals negative B plus or minus square root B squared minus 4AC all over 2A.
What?
Why did I write? I meant 21.
Yeah, I was wrong. This song is like that.
You did it wrong.
Where the numbers come from? The numbers come from A, B, and C. They're the coefficients.
Once we do our rep, maybe you'll understand.
They are the coefficients for the.
Yeah. What does it do again? Just to make sure that that's remember it.
And just have to watch your signs. So, in this case here, when you get your solutions out, you might have one positive value and one negative value. Can you have negative time? No, unless you're driving a 1988 DeLorean or doing 88 miles an hour in a DeLorean.
It took a while.
Thank you.
We're going back in time.
Yeah.
It's from Back to the Future.
Yeah, I'm not stupid.
Well,
It would have been a lot funnier if I would have said it without throwing up while I was saying it. Okay? That's what you're able to do with these things. Okay? Remember, when you're dealing with quadratic formula, it solves your zeros. It's figuring out your values. You're solving for x, if you will. All right? You also you're going to tell positives and negatives. You have to be able to throw out when you have the possibility of a negative. You cannot have negative time. That's how that works out. When you're dealing with the parabola starting at a 0 point to an end point, your axis of symmetry is your midpoint. How do you find the axis of symmetry given a standard form of the equation? Remember, if I'm dealing with the standard form of equation, it's ax squared plus bx plus c. How do I get my axis of symmetry? What is it?
X equals a squared minus bx.
It's
What was it?
Divided by 2.
Very good.
Something like that.
Oh, yeah.
That's your axis of symmetry when you're in standard form. Okay, that's always going to be your axis of symmetry. Your axis of symmetry, what was it? A x minus h quantity squared plus k. Vertex form. What's your axis of symmetry here? H. Very good. No, remember it's the opposite h, always. So it was x minus 2, it would have been x equals 2. If it's x plus 4, it would have been negative 4. That's what it is. Okay. So here's what I want you to work on then for now. It's a mixture again of these last two sections. Give you a little bit of time to ask some questions. On page 287, 62, 72, and 90. And then on page 296,
I do the same thing.
46 through 55, 75, 77, and 78. This is 5 stuff. This is 5.6. One reminder, and I'll start walking through 62 here in a second. I'm giving you guys 62 and 72 again because they deal with fractional amounts.
Great.
We need to worry about how to get rid of fractions because we didn't do very well on that on the quiz.
Yeah.
Also, on the 46 through 55 problems, those are choose your own adventure. Figure out whatever method you want to use to solve. There are some of them that are quicker to solve via factoring. There are some of them that are quicker to solve with quadratic. And there are some that are quicker to solve by completing the square. When we get to the test next week, I will ask you to do a specific method. All right, I'll say complete the square with this problem. Solve by any means for these problems. Something like that, okay? Give you guys a second to write that down. I'm going to re-explain to you how to set up number 62.
Yeah.
I'll collect all this tomorrow. All right? I'm collecting this tomorrow.
I know that.
That's good.
I accidentally did email.
No, you just got to collect.
Please.
Let me briefly walk you guys through how you start this one.
We do them all, right?
In this case here, you have denominators of 24, 2, and 6. What I want to do is figure out how do I get rid of all the fractions. Yes, sir?
Can you multiply by 24?
Yes. You always want to multiply everything by the least common multiple. Remember, that's what that means is the smallest number that all of them go into. I can't multiply everything by 2, the fractions won't go away. I can't multiply everything by 6, the fractions won't go away. But if I multiply everything by 24, I'll go back to it. What happens here is the following, and we might not have shown this very clearly, that might have been one of the problems we had some issues with, is this is what happens. You're multiplying each term, all 4 of them in there, by 24. So you get the following, 24 x squared over 24 minus 24x over 2 plus 24 times 13 over 6 equals 24 times 0. Now, in essence, you probably don't need to write that step down because you could probably, in your head, know what's 24 divided by 24. What's 24 divided by 2? What's 24 divided by 6?
4.
What's 4 times 13?
52.
And what's 24 times 0?
Is that how that one in the test worked out?
Exactly. Basically how you set this up last year. Now, I have to make a decision. What times what's positive 52 that I add together to get negative 12? Or I set it up and I try to complete the square.
Sorry, it's easier.
What's that?
It's easier.
It's a lot easier to complete the square on this one. Because you've got a nice number to work with 12. So, first step of completing the square is move your 52. You get x squared minus 12x blank negative 52. What's half of 12? Half of negative 12?
Negative 6.
And where do I put that negative 6? In the parentheses, good. What's negative 6 squared? Add it to both sides. 36 and negative 52 is? Positive or negative? Negative. And now I just have to take the square root. What is the square root of junk squared? Okay. What is the square root of negative 16? Very good. 4i. And then your last part would be add the 6.
It's equal 6.
Yeah, I did not do this.
Okay?
Wait a
Could you go to the original problem?
Yeah.
Okay.
It's 62 in your book, so.
Oh, it's 62?
Yes, sir.
You know what your formulas for
It's in your book. It's on the page right before it. I do believe the problems that you have talk about using the model in example, blah blah blah. But I'm gonna put back up the problems themselves.
What'd you get for that answer?
6 plus or minus 4i. Yes,
Okay.
ma'am. Oh, 77 and 78. Yeah. So yes, 77 through 78. It took a second. It's Monday. It happens.
I wrote 77.
All right, you guys got a good 10-minute head start here. Go ahead and get started here.